Hello, my name is Eva Sciacca and I am a postdoc at the Astrophysical Observatory of Catania at the Italian National Institute of Astrophysics, and I collaborate with Ugo Becciani IT group focusing on scientific visualization and distributed computing infrastructures. During this lecture, I will introduce you to the VisIVO Science Gateway and an application which provides access to the gateway named VisIVO Mobile. First of all, let's see the motivation of building a gateway for visualization-based applications in astrophysics. We deal with several terabytes of data coming from cosmological simulations or large-scale astrophysical observations. Such data volumes require the usage of distributed computing infrastructures to perform data analysis, storage, and access, and visualization plays an important role to understand, interpret, and verify their intrinsic characteristics. A collaborative environment let the users need to share visualization experiences, interacting simultaneously with astrophysical datasets, giving feedback on what other participants are doing or seeing. And finally, workflow-driven applications are useful to reproduce specific visualization results, since it may be difficult to select suitable visualization parameters. This is the summary of the lecture. First, I will introduce you to the employed visualization and analysis tools based on the VisIVO software. Then I will tell you the main functionalities of VisIVO Science Gateway and the VisIVO mobile application, also showing you a demo and a case study on muon particles analysis. And finally, I will point you to some reference material. The VisIVO tools are mainly designed for multidimensional data exploration, supporting a large set of astrophysical datasets, but also useful for any kind of multidimensional tabular data. VisIVO consists of a family of integrated, complementary, and independent tools, a desktop application, a command line tool, a C++ library, but for this lecture I will concentrate on the Science Gateway and the mobile application. The main core functionalities are the importer to translate the input datasets of different formats into a common internal format called VisIVO binary table. Then the filters are applied to analyze the dataset, for example, to remove outliers or extract subregions of interest, and the visualization tool based on the Visual Toolkit library to generate the multidimensional images. The generated images are, for example, two-dimensional plots of field statistics, point visualization, isosurface visualization, point glyphs, volume rendering, and visualization of volume slices. The VisIVO Science Gateway was developed on top of WSP grade GU's framework to provide a workflow-enabled grid portal for visualization and data management services. It offers two different roles. Standard users are provided with easy-to-use web interfaces to submit already made workflows developed by a workflow developer, and advanced users who can develop and configure workflows directly using WSP-grade functionalities. This is the overall architecture. The user community can access the gateway from the web interface and from the mobile application. The gateway is deployed on two different servers, one for the backend and one for the front end. The customized VisIVO portlets uses application-specific modules API to connect to the GU's services, while the mobile interfaces employs the GU's remote API. The gateway is deployed on these servers and it is connected to the Tree-Grid LSF cluster and the G-Lite Cometa grid. Those are some portlets submitting specific VisIVO importer, filters, and viewer workflows, and a particular portlet to manage user data. This portlet allows the generation of a panoramic movie to give a general overview of the dataset. It is generated moving the camera position of 360 degrees in azimuth and 180 degrees in elevation. Those are some workflows for the dataset remote importing, which also extracts useful metadata such as the histogram of the fields, and this is the parameter sweep workflow to generate the panoramic movie. Those workflows can be configured to different distributed computing infrastructures using the GU's TCI bridge. The VisIVO mobile application allows the mobile access to the gateway from a mobile device. Users can log in using the same gateway credentials. It is possible to navigate through the data, images, and scientific movies produced on the gateway, to visualize interactively the dataset, and to submit existing or ready-made workflows, and create new workflows using the graph editor. Now let's show a demo. This is the home page of the VisIVO Science Gateway. Choosing the VisIVO tools, you can import using the VisIVO importer portlet your dataset. We now select a gadget dataset of a large-scale cosmological simulation. A workflow to import the dataset to the gateway will be submitted. The workflow will extract all the useful metadata and update the VisIVO database. In this case, two tables are created, gas and halo. They are available in the file management portlet. When you click on it, you can access the related metadata, such as the creation date, the number of elements, and the histogram of each field. VisIVO filters converts imported datasets. In this case, we perform a randomization operation which extracts a subtable percentage of the input table. From the viewer portlet, you can visualize your data by setting the coordinates, a camera position, a palette, and other useful options. VisIVO Science Gateway allows the users to generate scientific movies. In this case, we right-click on the dataset and select a customized movie. By right-clicking on the image on the file management portlet and selecting panoramic movie, you can submit a workflow which creates all the images needed for the movie. Those are some images from the VisIVO mobile application. With the login, you can access to the dataset and see all the relative metadata. You can share them with your colleagues, sending an email. You can explore your dataset interactively. You can share the produced images and movies on common social networks as Facebook. And this is a case study of the usage of the gateway to visually inspect nuclear material inside cargo containers, analyzing the scattering of cosmic radiation particles called muons. The muon particles deviate their track in the presence of high atomic number material. In this case, we consider a muon tracker consisting of 4 planes. A data file provides the coordinates on the muon tracker planes as input. We obtain the scattering deflection of the muon particles and we filter the results from the noise. Then we can visualize the dataset and produce useful images and movies comparing different filtering processing with the original unfiltered dataset. Those are some results on a container containing the illicit material shaped with the string CT. We show the point visualization, the filter application, the point distribute to create the volume, and the volume tomography's visualization. And this is the workflow for the muon analysis. We have here the input dataset, the processing of filtered dataset, and the processing of unfiltered datasets, and the algorithm to generate the angle deviations. This is the portlet interface we have developed for this case study. Those are some results of isosurface rendering of the filtered and unfiltered datasets, and the panoramic movies showing the filtered and unfiltered datasets. Those are some tomographic images. Finally, I want to conclude pointing you some additional material. Thank you for listening. Goodbye.